Now it is.
Yes, ma'am.
It says that given, you have given A is the point minus 3, 2. B is the point 1K. So determine K. If the first one, AB, is parallel to 2y minus x equals 6, and the second one, if AB is perpendicular to minus 3y minus 2x plus 9 is equal to 0. Okay, the first one, the perpendicular one, no, I want the parallel one. Why am I so stupid? The parallel one. You know, if it's parallel, gradients are equal. Right.
Yes, ma'am.
So now you have the gradient of AB. That is now K minus 2 over 1 minus 3. So that gives you K minus 2 over 4.
Yes,
And then if you have the line 2y minus x equals 6, you must first write it in the form y equals mx plus c. So then you see 2y is equal to x plus 6, and y is equal to a half x plus 3. Do you agree with me?
Yes, ma'am.
Because there's 1 and I divided it by 2. So the gradient here is a half. So the lines are parallel. So that means that K minus 2 over 4 is equal to a half. Because I got it there and there.
Yes, ma'am.
Do you see? Okay. So now I say cross multiply. I cross multiply. And cross multiply, so I have 2 times K minus 2 equals 4 times 1. So 2K minus 4 is equal to 4. Eh?
Yes, ma'am.
And 2K is then equal to 8. Then I divide by 2, and then K is equal to 4. Have it.
Yes, ma'am.
Okay, now we come to the perpendicular ones. That means gradient 1 times gradient 2 is equal to negative 1. Okay, so now let's just get back to the sum. The gradient of AB we've worked out is K minus 2 over 4. Because it comes from there. Now you have the other line, minus 3y minus 2x plus 9 is equal to 0. You must write it now in the form y equals mx plus c. So minus 3y is then equal to 2x plus, now minus 9. Do you agree?
And why is it minus 9?
Because on this side it's plus 9.
Oh,
Understand?
yes, ma'am.
Okay, now I will divide by minus 3 because I want the y alone. So then I have that y is equal to minus 2/3 x plus 3. So now I take this gradient, I take this gradient, and I take this gradient, and I multiply them.
Yes, ma'am.
So I have k minus 2/4 times minus 2/3 is equal to minus 1. So then we use the minus always with that numerator. Ne? On top is numerator, below is denominator.
Yes, ma'am.
So then I multiply this and with this, so it gives me minus 2k plus 4 over 4 times 3 is 12 is equal to minus 1 over 1. Okay. But what I do now is I take this just to that side. So it gives me minus 2k plus 4 is equal to minus 12 because I multiply. So minus 2k is equal to minus 16. Then I divide by minus 2. So k is equal to 8.
Yes, ma'am.
Right. Inclination. Okay, let's do one of them again from the inclination. So you have the gradient with the line inclination. So we're going to say determine the gradient of a line with inclination of 135 degrees. Okay, now we say theta is equal to 135 degrees. So the gradient is equal to
10 theta.
tan theta. So we say the tan of 135. That second quadrant is 135 is 180 minus 45. So that's second quadrant, and that means that tan is negative. You know that.
Yes, ma'am.
And the tan of 45?
It's 1, ma'am.
1, but then it's minus 1. Alright. Find the inclination of the following lines. Okay. So I'll do that now. I'll just do one example just to revise it good. Find the inclination of the line 3y plus x is equal to 6. So inclination, you always remember, has something to do with the gradient. And the grade, you must also have the line in the form y equals mx plus c. So first I say that 3y is equal to minus x plus 6. Then I divide both sides by 3. So y is equal to minus a third x plus 2. Do you agree with that?
Yes, ma'am.
Okay, now you say the inclination. So you first work out there. Shift tan minus 1. But you never use the minus in a shift function.
Yes, ma'am.
So you say 1 divided by 3. So that gives you how many the angles?
Ma'am is 18,43.
Okay, 18,43.
43.
But now you must know inclination is negative. So theta is then equal to 180 minus 18,43. And that gives you
Ma'am, 161. 161,57.
do you have it?
Yes, ma'am. So, ma'am, this will always be negative.
Yeah, if the inclination is negative. If it's not negative, if it's positive, you use that one.
Okay, ma'am.
Okay.
Yes, ma'am.
Okay. So we carry on. But I think I just want to save this one because I think if